So this is the lesson 4.4, and now we're going to look at the practice problem. Oops, that's not practice problems that we skipped. So the odd 2 to 10 in lesson 4.4. Okay, so we're going to start with number 2, which is 6 to the power of x equals 3 to the power of 2x minus 1. Since the x is in the exponent, we're going to use the definitions of logs and write natural log of 6 to the power of x equals natural log of 3 to the power of 2x minus 1. And now we can bring the exponent down by the properties. 2x minus 1, natural log of 3. We're going to distribute the natural log of 3 here. So x times natural log of 6 equals 2x natural log of 3 minus natural log of 3. We're going to go ahead and subtract the two, or move everything that has x's to the left. So we end up with x natural log of 6 minus 2x natural log of 3 equals negative natural log of 3. And now we can take the x out. Natural log of 6 minus 2 times natural log of 3, because both of those have the x as a factor. And next, we're going to divide to isolate the x. So x equals negative natural log of 3 divided by natural log of 6 minus 2 times natural log of 3. And when we put this in the calculator, again, remember to put this inside parentheses, we get 2.710, or do it as separate, like calculate the natural log of 6 and 2 times natural log of 3 first, and then subtract, and then do the division. So that's another option. Okay, so that was number 2. Number 4 is e to the power of 0.1x equals 11. So again, we've got x in the exponent, so we're going to use the definition of log and do natural log of e to the power of 0.1x equals natural log of 11. Now we can use the properties and bring the 0.1x to the front. Natural log of e equals natural log of 11. Now remember that this here equals 1. You can put it in the calculator if you're not sure, but 0.1x equals natural log of 11. We divide by 0.1. So we get x equals 23.979. And that's it. Again, you can always go backwards and check. I did not mention that in the previous, or the original video, but you can always go back and plug this in. 0.1 times 23.7979. And this should equal 11 when you plug it in the calculator. So 11 and 11. Now, of course, we are rounding here some numbers, so this might, but it should round to an 11. Okay, next one is going to be number 6, which is the log with base 2 of 4x plus 1 equals 5. Um, we're going to use the definition of logs with this one since the x is in the argument. So 2 to the power of 5 equals 4x plus 1. 2 to the power of 5 is 32. We're going to subtract 1 from both sides, and we get 31 equals 4x. Divide by 4, and we get x equals 31 over 4. And going back to the checking, you should always check. Just because, if you get one of the extraneous um, solutions. So that should be something that you do anyways. All right, let's go on to number 8, which is log base 5 x plus 2 times log base 5 of x equals 3. Now, we're going to use the properties of logs. We're going to go ahead and move this 2 to be the exponent. So we're usually we do it the other way around, but you'll see why we're doing it this way for this one. Because now we have a addition here, and we have the same basis for the logs. We cannot have that 2 in the front when we're using the property, the product property. So now we can rewrite it as log with base 5 x times x squared equals 3. And now we can use the definition 5 to the power of 3 equals x times x squared, which 5 to the power of 3 is and equals x cubed. So we have the same exponent, so we know that our bases are going to have to be the same, so x equals 5. Okay, next one. We're going to do number 10, log base 2 x plus 1 equals log of base 2 2x. Okay, we have the same basis for the logs here. And so what we can do is we can use the 1 to 1 and set the arguments to equal. Now I'm going to subtract x, and we get 1 equals x. And that's it. That one was pretty easy compared to the other ones. Okay, next, let's look at number 12 here. So log with base 3 x plus 1 minus log with base 3 x minus 1 equals log with base 3 x. Okay, we're going to use properties of logs in this one. We have a subtraction, so we can rewrite it as a division. X plus 1 over x minus 1 equals log with base 3 of x. Now we have log of base 3, so we can use 1 to 1 next and do that. Say that the arguments are the same. X plus 1 over x minus 1 equals x. We're going to multiply by x minus 1 both sides. X plus 1 equals, and I'm going to distribute this, so x squared minus x. I'm going to move negative x and 1 to this side. So we get 0 equals x squared minus 2x minus 1. Now, we're not able to factor this, so we're going to use the quadratic formula again for this one. So ax squared minus bx plus c. So our a is 1, b is negative 2, and c is negative 1. So x equals negative b plus minus, and then we're going to start the square root, b squared minus 4 times a times c divided by 2 times a. Okay, the negatives cancel each other out, and we get 4 plus 4, which is 8. 4 or 8 can be factored to 4 and 2, and square root of 4 is 2, so we can take that out. And we can cancel the 1s because there's 1 on the bottom, and both this and this have a 2. So we can cancel those out, and we get x equals 1 positive and negative square root of 2. Okay, now we need to check what these are. So 1 plus square root of 2 is going to be 2.414, and 1 minus square root of 2 is going to be negative 0.414. Now, looking at our original, this one right here, if we plug in that negative 0.414, that's going to be a negative. So this cannot be, or that's an extraneous solution. So 2.414 is going to be the answer. Okay, so that's it for these problems. Again, please don't hesitate to ask any questions if you've got any. Bye.